First thing I want to do on example 5 is figure out what does theta equals pi over 3 look like when you were graphing it on a polar grid. So picture if you have all the points, no matter what r is, the theta is pi over 3. So we can envision this, on a polar grid, and mine's just going to be a small polar grid, but you have all the different circles here. Mine are clearly not the best circles, but envision pi over 3. That angle is right here. So if you were plotting the point 1 pi over 3, you would have a point here. 2 pi over 3, 3 pi over 3. Or what about negative 1 pi over 3, where we cross over that pole and it goes this way? Or negative 6 pi over 3, something like this. All of these points end up creating this line. So in the end, when I'm converting this into rectangular coordinates, I'm going to get a line, something like y equals mx plus b should be my final form of the equation. So think about what we know about theta. On the front page, we know that theta equals the inverse tangent of y over x. So one thing we can do is we could replace theta with that. So we could say that the inverse tangent of y over x equals pi over 3. Now our job is to solve for y. So the next thing that you could do is you could go ahead and you could actually take the tangent of both sides to kind of cancel out the inverse tangent here. So if I took the tangent of this side and then take the tangent of pi over 3, so these would essentially cancel. We'd have y over x equals the tangent of pi over 3. Now hopefully at this point we know the tangent of pi over 3 is root 3, so we could write that in. So we'd have y over x equals root 3. And remember, when we're in rectangular coordinates, our goal is to get y by itself, like we have over here. So if I were to multiply both sides by x, we would get that y equals the square root of 3 times x, which fits our y equals mx plus b form. It's really saying basically that the root 3 is your slope and that it goes through the origin, which we knew that that would happen as well because there's no b value. Now, this isn't the only way to go about doing it. From the very beginning, when you had theta equals pi over 3, you also could have jumped to right here, just taking the tangent of both sides. So you could have said that the tangent of theta equals the tangent of pi over 3. And that's helpful because we know that the tangent of theta is y over x. So at this point, you replace it with y over x. Tangent of pi over 3 is root 3. And then you get the exact same answer. It's just kind of in a different path. So it's up to you either way, but if we look at Desmos, y equals the square root of 3 times x, you can see that it is that line with a slope of root 3. You could envision that polar graph kind of sitting over it and how this would be right along the angle pi over 3.